FRQ 257 starts off with a graph, and it tells us that that graph is f, and then it says that g of x is the integral from 0 to x of f of t dt. So g of x is the area under the curve, right? The function for the area under the curve. And so this is a derivative function, right? This is a level 2. So the first thing it asks is find g of 4, g prime of 4, and g prime prime of 4. So I know we've done some of these, but it's good to refresh. So g of 4 is equal to the integral of 0 to 4. So just like go back, what is g of f of t dt? And this is where we're going to have to use geometry. Now, it doesn't have an initial amount, so it's nothing at the beginning, so we can just look from 0 to 4, what's the area under the curve? That's what this means. Area under the curve, and you're using geometry. Okay, we've done a bunch of these. Well, so this we're going from here to 4, right? So these two cancel each other out, right? So we're just looking at this area. And this area is 2, and this area is 1. So we can just say that that's equal to 3. So I'll just do it right here, equals 3. Now g prime of 4 is just f of 4, right? Because if we take the derivative of g of x, if we take the derivative of this, we just have f of t, right? So, and then if we put a 4 in, it's just f of 4. So f at 4 is 0. So g prime of 4 is 0. And then g prime prime of 4, do you remember how to do this? This is the second derivative, and so if this is the first, it means what's the slope, right? What's the slope of this? So the slope is, you can use these 2 points they gave you. They gave you 3, 2, and 5, negative 2. So negative 2 minus 2 over 5 minus 3, which equals negative 4 over negative 2, which is equal to positive 2. So there's your 3 numbers, 3, 0, and, oh wait, was this is a positive, so that's a negative. Be careful, Mary. Okay, so that is part A, and okay, let's go on to part B. I think we can do this all in one video. Does G have a relative minimum, a relative maximum, or neither at x equals 1? So we're looking at x equals 1, and we need to know whether, here's x equals 1. Let me use right here. Oops, right here. And what's happening to the derivative at x equals 1? Well, it's changing from negative to positive. So that's a simple answer. G has a relative minimum at x equals 1 because g prime of x, which is equal to f of x, changes, and don't leave this out. This relates the g that they asked about to the graph you're talking about. Changes from negative to positive at this point. Okay, so we got that. That's good. And let's go on to part C. Suppose that f is defined for all real numbers and x is periodic with a period length of 5. So f would just keep continuing like this. So it would just go, like here's 2 periods. So one up here, da-da, up here, da-da, okay? So if you want to know g at 5, you would go, how much is this? And then you could keep combining it. So, all right, sorry. The graph shows 2 periods. Given that g of 5 is 2, okay? And so g of 5, they're telling you, is 2. All right, so, okay. Find g of 10 and write an equation for the line tangent to the graph of g at x equals 108. Okay. Now you might wonder, where are they getting this g of 5 is 2? Well, if you add, you have to go from 0 to 5, and so you have two negative triangles. And aren't these the same as these triangles? So you're just left with this piece here, which is 2. So that's where the g of 5 is 2. So we want g of 10. So wouldn't g of 10 equal 2 times g of 5, which is going to be equal to 4? So that's the first thing. Now it says write an equation for the line tangent to the graph at x equals 108. Oh my gosh, so we want g prime at 108. And we need the y, so we need, that's the slope, and g of 108 would be the y coordinate. So we have a point 108 and then g 108. So there's your point, and here's your slope. So, okay, first let's go with g 108. Well, look, all we know is that g of 5 is 2, but it repeats itself. So how many g of 5s are in here? So if you do 108, right, divided by 5, that's equal to 21, right? So that's 21 times 2. That would be the g of 5s. And then you have to go plus integral of 0 to 3 of f of x, right? So let's just say that, let's just write it out. 21 times 2, this equals 21 times 2, plus the integral from 0 to 3 of f of x dx. And so that's 42, right? 42 plus, and then if I just go to 3, okay, so going back over here geometry-wise, going to 3, this and this knock each other out, so I really only have from 2 to 3, which is 2 again. So plus 2, that's 44. So I have 108, 44 as my point. And now g prime of 108. So how do you figure out g prime of 108? So you would just do f of 108, right? And f of 108, okay, see how this is f, right? Okay, let me do it in green. This is f. So if it keeps repeating itself, f is at -2 at 5, right? So we already know that it would be here at 100 and 105. It would be back down here. So then we have to go 3 more. So it would be here. It would be at 2. The y it has 3 more. So x equals 3 more would give you a y of 2. So f of 108 is 2. So we would say y minus 44 equals 2x minus 108. So y minus 44 equals 2x minus 108. Okay, now let's add up all the points. Going back to the beginning. Sorry. Part A was worth 3 points. So you get a point for getting 3. You get a point for getting 0. And you get a point for getting -2. So there's 3 points for part A. Part B is worth 2 points. You get a point for saying it's a relative minimum and the reason. So 2 points total for B. So now we're at 5. And then part C is worth 4 points. So you get a point for getting 4 here, getting G of 10. You get a point for getting 44. You get a point for getting 2, and you get a point for the equation. So that was 4 points for that. So that was FRQ 257.